Okay, so good morning. Okay, so we're now don't care conditions. So we only have around 3 topics left. So again, good morning. So again, we have 3 topics left. So we have don't care. We have universal gates and design problem. Okay, worded design problem. Okay, so we're actually already designing. Okay. So with 7 segment, okay. So it's actually designed already. Okay. Were you able to finish your assignment? Submitted already? Have you submitted your assignment? Please type here in meeting chat. So I have a feedback. Okay. I need a feedback. Okay. Okay. So it's any question about designs? Okay, mapping. Okay. So it's actually a design already. Okay. Hey, Bren, you have to submit. It's been a week already. Okay. You have to submit it. Okay. So how many are you? I only have 3 students. So what happened to the others? So as days drags on, so the attendee to my class is getting less and less. Okay. Why? It's making me feel sad. Okay, so we have here don't care. Okay, so let's start. Don't care is a conditions wherein you don't care at all. Okay, don't care to a person. Do you know what's the opposite of love? Any idea what's the opposite of love? I only have 3 students here, so all of you should answer. Donald, Justin, and Bren, what's the opposite of love? Justin says hate. How about Bren? Bren. And Donald, what's the opposite of love? Hate also. And Bren? Okay, same answer. Hate. Okay. Uh, Let me give you a life lesson for today. Okay. The opposite of love is not hate. Okay. The opposite of love is not hate. It's actually don't care. Okay. We don't care about the person, so it means that the person you don't love that person anymore. The person doesn't have any effect on you. Okay. When you hate the person, you actually have a bit of concern about the person, or it has a certain uh, effect on you, or the person has affects you in a way or another. Okay, so therefore you may have a little concern, okay, or a lot of concern. That's why you hate the person. Okay. You hate the person because the person doesn't go with whatever's on your mind. Okay. So that means that you still have a love on that person. Okay. But that's why hate is not the opposite of love, but it's don't care. When you don't care about the person, so you're not concerned. So what's going on with that person? Okay. Okay. So that's the reality. Okay. So now you know the reality, the opposite of love is don't care. Okay. And we have it here. Don't care. Okay. So our lectures, although this is circuits, okay, can actually be applicable in real life. See? So like here, don't care conditions. So there are certain conditions that cannot be answered by yes or no. Okay. Yes is logic 1, no is logic 0, okay, or otherwise. Okay. There are certain conditions that can be answered by maybe. Okay. So that is don't care conditions, or it doesn't matter. Okay. So that is also don't care conditions. Okay. Don't care conditions is signified by X. So when you say X, X is usually known, usually used as unknown. Okay. Or it doesn't matter. Okay. So don't care conditions happens when a design problem implies that certain conditions will never exist. By the way, can you see the PowerPoint presentation? PowerPoint word presentation. Can you see the word presentation, class? Please give me your feedback. Can you see the word? Okay, thank you. Okay, so let me continue. Okay, don't care conditions here. So let's have an application. So same problem. Okay. So design a BCD. What is again BCD? BCD is a binary coded decimal wherein again, each digit in decimal is represented by how many bits in binary? When you say BCD, how many bits in binary? Let's say 0. So how many bits in binary? So let's say decimal 0 is to be represented by, thank you, Justine, Bren. Okay. It is to be represented by 4 bits in binary. Okay. Thank you for your feedback. Okay. Yes, thank you. Okay. Okay, 4 bits in binary. Okay, so actually that's what we did last week. Okay, so we did that last week. This design, okay, BCD to 7 segment decoder, okay, but without don't care condition. So let's have a recap, okay, of what we have discussed. Okay. Okay, so we have discussed last week 7 segment, and then we were asked to solve for. Okay, so this is the truth table. Okay, so this is the truth table. Okay, for 7 segments. So this is actually a design problem. Okay, BCD to 7 segment, but the outputs are either 1 or 0. Okay, there are only 2 possible outputs, 1 and 0. So, okay, any question about this one, class? Do you have any questions with regards to our last week meeting, last week lecture? Okay,
None
so
po, ma'am.
okay, so let's proceed with same problem. Okay, so actually we'll have the same problem, BCD to 7 segment. Okay, wherein again each number in decimal is to be represented by 4 bits in binary. Okay, so what if, okay, so let's have an application of this using don't care. Don't care allows you to have simpler design. Okay, don't care allows you to have lesser literals. Okay, so let's say design a BCD to 7 segment wherein you only desire to have an output display for 0 to 9 only. Okay? So meaning that you don't care about 10 to 15 combinations. So the assumption here is that 1010, 1011, 1100, 1101, 1110, and 1111 input combination won't happen. Okay? So since this is a BCD to 7 segment, so BCD, so meaning it only represents 0 to 9, decimal 0 to 9. So therefore, the input combinations would only be from 0, 0 until 10, 0, 1. Okay, so the assumption here is that, again, combination 10, 10 to 10, 11 up until 11, 11 won't happen. Question, class? Question about don't care? Okay, so when you say don't care, the assumption is that certain conditions won't happen. So, hindi siya mangyayari. Okay, so that's why you'll never mind what will happen. Okay, so deadma lang siya, deadma. Okay, so in that case, okay, so since the certain conditions won't happen, so the output would be x. Okay, x. Okay, so what would be the impact of that x? Okay, output x. Okay, again, x could mean 0 or 1. Okay, so let's say we have this. This is for a. Okay, output a. So we have x from 10, 10 to 11, 11. Okay, so from 10, 10, 10, 11. Okay, and okay, 1100, 1101, 1110, 1111. Okay, and then we have 0 for 001 and 0100. 001. Okay, 001 and 0100. Okay, the rest are 1. Okay, so this is the looping for A. This is the K-map for A. Any question, class, before we proceed? Don't hesitate to ask. Okay, any question? Shall we proceed with don't care?
Welcome, ma'am.
Okay, okay, let's proceed. Okay, let's proceed. Okay. Okay, so since let's have this say obviously a mean term. Okay, so again, A is equal to, okay, so let's have the blue loop. Okay, so as you can see here, okay, x can be treated either as 0 or 1. Okay, it may or may not be included in the loop. Okay, so you are not compelled to use x if not necessary. However, I included x in the loop, okay, because the more outputs in a loop, the lesser the literals. Okay, so let's have what is the Boolean equation here for the blue loop. Okay, what would be the term? Okay. So for the blue loop, so again, so we have two values for jk. We have 1, 1 and 1, 0. Then compared k 1, 0. So what will happen to k?
Eliminated.
Okay, so we have eliminated. K would be eliminated. Okay, whereas j 1, 1. Okay, j is, what will happen to j?
J po.
Okay, j. Okay, and then for L and M, okay, we have four values 0, 0, 0, 1, 1, 1, and 1, 0. The compared L, 0, 0, 1. What will happen to L? What will happen to L? Okay, again, L, 0, 0, 1. What will happen to L?
Eliminated po, ma'am.
Okay, J is eliminated, whereas M, 0, 1. Okay, so we have 0, 1, then M is, again, eliminated also. Okay, so as you can see, if we have 8 in a loop, so we will only have one literal. Okay, so we're only left with J. Okay, next is the red loop. Okay, red loop. Okay, so again, we included X. Okay, so that will have more output in a loop. Okay, so more output in a loop, that means that we'll have lesser literals. So what would be that literal? So with regards to JK input, so we have 0, 0. We have 4 values, 0, 0, 0, 1, 1, 1, 1, 0. Okay. Compare J, 0, 0, 1. What will happen to J? What will happen to J? 0, 0, 1, eliminated. Okay. So thank you, Bren. Eliminated. J would be eliminated. Okay. So how about K? 0, 1, 0, 1. What will happen to K? Eliminated again. Okay. Thank you, Justine. Okay. So both J and K would be eliminated, okay, for the red loop, okay. With respect to L and M, okay, so we have two values, 1, 1, and 1, 0. So compare M, 1, 0. What will happen to M? What will happen to M?
Eliminate.
Okay, eliminated. And whereas for L, 1, 1, L is L is L is
L po.
1, so okay, so simply L. Okay, so for the red loop, so it's simply equal to L. Okay, so again, with eight outputs in a loop, okay, so we're left with just one literal. Okay, so how about this orange loop? Okay, so we have 4 in a group. We can actually have just this. Okay, we can actually have just 2 members. However, again, with more outputs in a loop, we can have less literal here. Okay. So for orange loop, okay, so we have two values for JK, 0, 1, and 1, 1. For K, 1, 1. K is K is 1, so we will write K is 1, so we
K.
will K, okay. How about J? 0, 1. J is J is
Eliminated po.
Okay, eliminated. Okay, with respect to LM, so we have two values, 0, 1, and 1, 1. So what will happen to L? 0, 1. What will happen to L? 0, 1. So L would be 1, 0, 1. 0, 1. If you have presence of 0, 1, so what will happen? L would
Eliminated.
Okay, eliminated, and M is 1, 1. Okay, so M is therefore M is equal to 1, so we have M. Okay, so actually you already got it right, Justin. Okay, so we have KM, and last we have the green loop, which is on the corner. Okay, so we have corners here. Okay, so we had the green loop because of this one. Okay, because the output for 0, 0, 0, 0. Okay, it has no group mates yet. Okay, but I group it with 3 others, so to make it 4 in a loop to have lesser number of to have lesser literals. Okay, so for green loop, so we have two values. Okay, so for JK we have 0, 0, and 1, 0. Which one will be eliminated? For JK, what would be the term? How do you equate JK? So what will happen to J
K po.
and K? So
K
it's just
prime.
simply equal to, for JK, simply equal to okay. So Justin says that for green loop, so it's just simply equal to K prime M prime. Okay, so why? So J would be eliminated. So 0, 1, so eliminated. So K 0, 0. So that makes it K prime. Okay. K prime. And again for LM, so we have 0, 0 and 1, 0. So compare L 0, 1. Okay. So cancelled. So M 0, 0. So it is M prime. Okay. Okay, so I guess this is already a reduced, simplified, so it cannot be further simplified. But Km plus K prime M prime, so what is that?
KX nor M po.
Again, what gate shall we use? K prime, Km plus K prime M prime. Tama ba? Okay, so what gate is this? Km plus K prime M prime. This is just simply what? It's like 1, 1 plus 0, 0. Would you have inputs 1, 1 plus 0, 0 is still equal to 1. What gate is this? Anyone?
X nor
XNOR
po.
po ba?
Yes, XNOR. Okay, so we'll use XNOR. Yes, okay. Ayan. Okay, XNOR. By the way, I asked you if there is a symbol for XOR. Have you found any?
None po, ma'am.
None.
Yun lang po.
La talaga, no? So it's only as there's only a symbol for XOR but none for XNOR. XNOR, none for XOR. Okay. So okay. So J plus L plus K. Okay. XOR M. Okay. This is the Boolean equation with don't care. Okay. So let's see what's the equation without don't care. Can we see? Let's check. What's this? Okay. Okay. Found it. Okay. So look, let's compare it with A without don't care. Okay. So what can you see? So what have you observed? So this was our equation last week. Okay. So what can you say? Any comment? Which one's
Mas may
simpler?
cheat po.
Which one's
Okay.
simpler? With don't
Yung with don't care.
with don't care, without don't care. Which one's simpler? Okay, so with don't care, thank you, Justin. With don't care. Okay, so you'll have lesser literal. So the letters here are actually called literal. So as you can see, if we have X nor, you can already implement A using just 4 literals, with just 4 literals. Okay. Okay, so we have just 4 literals here, whereas here we have how many? 2, 4, 7, 9, 11 plus 3, 14, 14 literals. Still numerous, okay? Still numerous. Okay. Any question? Did you get the same answer? L plus J plus K. Did we get the same answer? So let's compare. Okay. We have J. We have the same answer also. L plus J plus K. Let's change this one. When I was doing this, I didn't know there was this symbol. So I only came it by serendipity. Okay, I only found out. Okay. Any question about don't care? Okay. So you have a seat work here. Draw the logic diagram for output A. Okay. So, and then, okay. So you have your seat work here for output A. And then again, you'll have an assignment. Okay, let's be consistent. So, who did letter C? Was it boys or girls?
Boys po.
Okay. So, assignment again. Output C for the boys and output D for the girls. This time with don't care. Okay? So, you have two assignments. Okay. One assignment and this is seat work. So, I'll be expecting your output here. I'll give you 30 minutes. Okay? So, this just easy. Okay? This just easy. Last question. Okay, so I'll be waiting while you're doing your assignment so that I'll know when you, so I'll be standby if you have any questions. Okay, please do your seat work so that if you have any questions, I'll just be here. Okay. Circuit for output A. So simple lang, just this one. Okay, activity 3.5. Yes, activity 3.5. Okay, only activity 3.5.